So before anything though, I just want to show a couple things. I had to make a quick change this morning to how the labs look. Before, the lab submissions, which are only required for people that are doing online asynchronous labs. So if you are in an in-person lab section, do not submit your labs. Don't. And if you think, well, I'll submit it anyways, it's actually better if you don't. So don't submit your labs if you are in an in-person section of the labs. Before, this was restricted to only, like, you shouldn't have been able to see it. It was only restricted to people that were in the online section, but because people in the online section of the class, some of them are in the in-person labs, and people in this section, or some of them are in the online asynchronous labs, it was just easier to open up to everybody and just let you know that only the people in the online asynchronous labs are to do the submissions here. Okay? Cool? Another thing to note, did you have a question or just a scratch? Just a scratch. Another thing to note, because I've been lonely in office hours the last 2 days, this is how you get to office hours. You just click it, it'll take you to collaborate, and then give it a second. Then it'll ask you which session to join, just for organization purposes. You go to this one. Yeah, for me it'll be slightly different because I'm the admin, and you just join. And my plan is that, like, if people come to office hours, it'll be first come, first serve. And if you have a question, I'd like to leave the question open for everyone to see your question, because a lot of times people come with the same questions. But if you want like well, no, I'd like one-on-one, I don't want other people, that's fine. We can create like a breakout session that only me and you are or something. So, as you can see, no one's here. But, whatever, that's how you would join. Cool? All right, let's back out of that and continue with the course. So, yesterday we actually didn't get very far. Barely even talked about the introductory stuff. I just gave a lot of background, a lot of syllabus stuff, you know. But we finished off by talking about which programs people were in or are planning on being in. And we saw that there was quite a range of people. People from science, people from business, people from arts programs, all over the place, which is really cool. So anyways, that's where we ended last time, that quick little activity. What you should bring to class, well, curiosity, ready to learn. There's no prerequisites, nothing really. Pencil and paper might be handy. A lot of like planning for programming takes place on pencil and paper, not in code. But if you can, you don't have to, if you can, it's really great to bring your own laptop. If you have it, you don't need to. But if you bring your laptop, you can participate in some of the activities that we'll do in Python. Otherwise, you're left with your pencil paper, which is fine. That's completely fine. But when you're doing an actual programming, because sometimes I'll have activities like that where it'll be like, okay, let's quickly write code to do this. And then you get a chance to do it. And you hit run and you see it done. So it gives you a chance to play around that way. If you're in the online section, well, you're not really bringing much to class, and presumably you're watching this on YouTube, or you're going through the notes, so you're at a computer of some sort. Do your thing. I actually even encourage you to, if you can, maybe you and somebody else you know, or a couple people you know are in the class, it'd be really great to like watch the videos together and go through it together so you have a chance to talk and talk about things you have issues with, maybe work on some of those activities together. That might be the best way to go about doing it. And if you're not comfortable doing that in person, well, I've got one in the Blackboard, in Collaborate Blackboard, or Blackboard Collaborate, whatever it's called. I've got one of the sessions is called like general chat. So you can go in there and enter some of the breakout rooms together and do it together, coordinate and whatnot. Because I want to make it as a similar experience for everybody. And I really want to design the class in such a way that everyone gets everything out of it, even in spite of the current weird situation. So the big question a lot of people are probably wondering is this class easy or is it hard? This is tricky to answer because everyone's different. Typically, first year computer science, for better or worse, kind of has a high fail rate. Because it is, I don't even want to say challenging, but it's not a class you can let get away from you. It's very accumulative. It's very, like if you missed last week's, it's not like, well, I'll just, whatever, write that off and start this week. Ugh. If you don't have that information from last week, you're in big trouble because it's so accumulative that you're going to be in real trouble. So this is not the type of class you can, it's not that it's hard, but you gotta keep up with it. But some people might find it really easy. Some people might find it very difficult. Everyone's all over the place. But one of the key things that we're trying to emphasize here, and this is a warning to people that have some programming experience. Weirdly, people who have programming experience will tend to actually do kind of poorly in this class. I don't really know why, but my bet is that those students think they know everything, but they really don't. And then next thing you know, it gets away from them. So just stay on top of it. But I'm going to be teaching you specific ideas, specific tools that you're going to put in your tool belt. And we're going to see a whole bunch as we go. And it's similar to me asking you, like, well, raise your hand if you know how to use a hammer. Put up your hand really high. Like everybody, right? Is using a hammer hard? No. You know how to use that tool. Do you know how to use a screwdriver? Of course, everybody knows how to use a screwdriver. It's just a simple tool. You know how to use it. What else do I have? A saw? Who here has ever used a saw? Of course you have. But the trick here isn't whether or not you know how to use the individual tools. It's how you use those tools to solve the problems. So just because you know how to use all those things, like everybody in the class raised their hand for those tools, raise your hand if you think you know how to build a house. One person? Okay, one. That's it. That's where the trickiness comes in. Now, mind you, first computer science, we're not going to do anything analogous to building a house with these tools. Don't get me wrong. But the trick is putting them together to do stuff. People, so many times, they come to office hours and they're like, look, I really understand the loops. I really understand conditionals. I understand the variables, the types. I know it all, but I'm having a really hard time putting it together. That's what you're learning, is the putting it together. Don't get me wrong, you're learning the tools, but a key part here is putting it all together. That's the trick. So that's what people usually find challenging, is taking the step back and using these tools to solve your problems. Okay, each of the things we're going to learn, I basically said all this, they're relatively simple. Should you be terrified? No. Okay, you're going to need help in this class, and fortunately, I've been teaching first year computer science for quite some time. I design my courses in such a way that you have a lot of resources. It's weird this year, I know, but resources you have, well, you have the lectures. The course notes are designed a way that you can sit down and just go through. I've got YouTube videos, not just recordings of these lectures. There's YouTube videos that I'll talk about more in a moment that cover some of the more challenging activities or parts of the class that are like one-off, quick little videos. I have office hours, there's labs. The TAs have office hours. I mean, they're going to be on Collaborate. There's lab TAs that have like lab office hours. There's a lot of resources available to you. They are made available for you for the help and support that you will probably need at some point. That's on purpose. Take advantage of these things. But one of the key things, and it's so much so that it's kind of a meme. I'm going to, and every year people complain about this, and I think it's funny. I'm going to tell people, if you come to me with a question, it won't be weird if I tell you, try Googling that. That's not me dismissing your question. I want to be very clear about it. I'm not telling you like, I don't want to be bothered to answer your question. I'll tell you to go Google it. Go see if you can figure this out on your own type of thing. Because that's what I want you to do. One of the key concepts and things that you got to learn in computer science is I'm stuck. But I got to find out where to find my solution to this problem. You're going to have a bunch of questions, and fortunately, computer scientists are pretty good at putting up problems and answers on the internet. Take advantage of this. There's so much information available. So much so that even like next semester in 162, I don't even really recommend a textbook because there's nothing a textbook could give you that isn't already on the internet a billion times over. This is such a common thing. It's a meme in computer science all the time. If you go on like the subreddit for programmer humor, you'll find one of these memes every other day. Here's one that I thought was particularly funny. Googling stuff doesn't make you a doctor. No, it doesn't. But it kind of does make you a programmer. If you're really good at Googling your answers to things, Googling your questions and getting answers, chances are you're going to be a damn good programmer. So one of the things I actually want you to learn is how to search for things, how to find these answers to your problems. That's a key thing. It's not me being dismissive. It's me trying to encourage that independent learning, which is critical in computer science and programming. Any questions so far? I know it's still a lot of background information, but I'd love to be able to answer any questions if there are any. Everyone's okay. Okie-dokie. So, did anyone here yet actually write any Python code? A couple people, yeah. So here's what we're going to do. We're going to write our very first program, Hello World. Hello World is traditionally the first program every programmer always writes. So we're going to write Hello World. We're going to write this. Now, if you haven't gone through the section of the class that says how to get set up for 161, you should go there and read through the stuff that you've got, the descriptions of things. There's a lot of options. But the thing that we're going to use is, here's the link. I give you a couple of options. One is use Google Collaborate. This is the one that I'm going to be using, and I encourage you to use. Because, and you'll see it in a second, because I'm going to load it up. Raise your hand if you don't have a Google account. See, that's what I thought. And people that sometimes think they don't, they actually do. They just don't realize it. So, Collaborate is the most accessible, easy way to access Python programming. You actually do your programming on some servers somewhere else, but you interface with it through a browser, which is really cool. It's really easy. But if you want to get, oh, and another really cool thing about this style of programming, it's very popular in academic settings, especially in the learning setting, because it's a notebook style programming, where you kind of like section off your code and you can add like notes to it and whatnot. It's perfect for a setting like a classroom where you can write some code and add some notes for yourself. I'll show you some of those neat little features in a moment. But if you want an actual Python distribution on your computer, you can go download all the stuff you need to be able to write Python code and run Python code from the internet. If you do that, I highly recommend getting the distribution of Python called Anaconda. It's just a particularly good distribution of it. It's got Python plus a lot of extras that are very handy. And there's a couple other options too that I don't really recommend, but if you want to geek out quite a bit, go for it. But the key big one I want to encourage here is Collaborate. And this is it. And let me show you how to get there. Oop. Just Google, oh no, not Collaborate, Colab. Google Colab. Just go to Google and type in Colab. And, wait, hold on. There. You type in Colab, it should be like the first hit. Go to it. You might have to check some boxes, and then you're there. First time you get there, you might be hit with a screen that looks something like this, like, oh, welcome. Maybe not even this. Maybe it'll be like a more general welcome page, whatever. Just say new notebook down here at the bottom, and you're all set. You should get something that looks something like this. Let's get rid of this code. You'll get something that looks like this. That's it. All of this stuff, too, that you write on Colab will automatically back itself up on your Google Drive. So very, 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 very little chance of losing all the work you've done in case of a weird computer mishap. So this is really awesome, and it's kind of unbelievable that Google just lets us do this. We get to use their servers to run Python. Pretty cool. So here we go. We're in Collaborate. Oh, and you can rename this you want. Like, lecture, whoop. My goodness. Let's just undo what I was trying to do and try again. There. Now I've named it lecture stuff. Cool. Now we're going to do Hello World. Okay? And here's how you do it. Can everyone at the back see this decently? Yeah? Here's what we're going to do. I'm going to give you a hint. Actually, here. I'm going to give you a test in 1 second. I haven't hit run yet. Most people in here have probably never seen a line of code like this before in their life. Raise your hand if that's you. Now, for those of you with your hands up, who thinks they know what's going to happen when I hit run? What? It's going to print it out? You don't think so? Whoa. Let's have a look. Well, it did. I gotcha. That's it. So try to hit run. Like if you're following along, try to do this real quick. That's Hello World. Pardon? Oh, there's a couple of options. Sorry, you can hit this little play button. You can also hit Control Enter. And then if you want to get really fancy, you can hit Alt Enter and watch what happens. Everybody watch. It's going to blow your mind. Whoa. What was different? It made like another little box below. So you can have as many boxes as you want. Do whatever you want. There's a bunch of ways to hit run. There's probably even a bunch of options. Don't worry, throughout the course of the semester, you're going to get a chance. You should take the time to poke around and see what you can do. I have the dark theme. You probably have the light theme. You can change this or settings. Poke around in there, see what you can do. Have fun. But that's Hello World. Raise your hand if you got it working. Quite a few people. That's wonderful. Now, a cool thing here is, you can add code. You can even add text. And you can be like, oh, okay, so, whoop. Uh-oh. Don't tell me Chrome's about to crash. Okay, never mind. So I'm adding text. There. And so see how you can add notes in and around your code? You might find this really handy. Maybe you don't, whatever. It's a cool option you have. So have fun with that. This is one of the benefits and advantages of using this notebook style programming. So, Hello World. Raise your hand again if you did it. Okay, so it looks like the majority of people. So now all of you, raise your hand if you had just raised your hand and never wrote code before in your life. Okay. The reality is, you now, you've programmed. That's a program. That's it. You're a programmer. Now you're probably thinking yeah, but it was so simple. Well, actually, let's take a second to think about all of this stuff that you just told the computer to do. You've done quite a bit here. You said, okay, computer, print this message out. It might seem silly, but okay. Who here knows how Python did that? Because you got to figure, okay, so Python knew it needed to print something, and it needed to get the thing that we wanted to print, right? I mean, the thing that we wanted to print was that thing that said Hello World. Okay, not too bad. But you figure, when I see Hello World, what is the computer doing? Well, it's got to know, what pixels on the screen to even, turn on. To turn white, to show the words Hello World. I mean, there's a lot going on here. This is actually quite a complex little function you just called for printing. The awesome thing is, it exists. Some programmers out there, years before you, wrote the code for what print means. Someone had to tell the computer, okay, when a programmer writes print, here's what you do. Someone wrote that for you. It's called a function. And you took advantage of that amazing complex print function to do what you needed it to do. It's pretty cool, right? throughout this course, we're going to learn how to write our own functions. And we're going to be making use of a lot of functions other people write all the time, which is really good. No sense reinventing the wheel if we don't have to. Imagine I told you, like, okay, raise your hand if you do have some amount of programming experience. Okay, so for those of you that just had your hand up, imagine if I just told you, okay, print out to the screen, but like that print function didn't exist. And you got to go and figure out all that under the hood stuff. If you asked me to do that, I'd be like, no, I'm not doing that. That's way too much work. Because someone did that for you. So I don't want to reinvent that wheel. So there we go. So here is one of the many links to the YouTube videos. I think this takes you right to my channel. I think. Yeah, there you go. And look, here's yesterday's video. It's already up. Only 38 views, which is concerning because there's 90 people in the other section, but whatever. So there you go. There's one of the links. And you can find the links on like the Moodle page too, and in other parts of the, I think it's on the main page of the CSCI161.com website as well. So there's a lot of places to get there. We don't want this anymore. So, a couple of big key things here. These videos are not substitutes for lecture or course notes. Well, that's kind of not necessarily true if you're in the online section this semester, of course, because that's all the lecture you get. But typically, if you're attending these, don't really think of them as replacements, because people tend to not treat recordings of lectures quite the same as being at a lecture. So be aware of that. And some of the videos, a lot of them are using the interpreter, not Colab, but all the stuff I write into like the black box thing is going to be the same. You can put into Colab, don't worry. And right now I'm talking about some of the specific short little videos talking about complex things. We'll see an example of that like right here. See how I've got like hello world printing some weird file there, and then over there I've got that black screen? That's programming like it's like 1985. And whenever I was doing it that way, you can write the same code in Colab and get the output like we would over there. It's very, very, very similar. It looks different superficially, but not that much different. But also, here's the big thing. And this really actually won't affect you very much, but one of the big things that will be different is those short little lectures, not the ones that I'm recording like right now, obviously, but those short little lectures are actually using a different version of Python. It's using Python 2. We're using Python 3 here. Now, it's true that 3 is newer, but there was quite a bit of time where 2 wasn't considered the old version, it was considered just like a parallel version. And 2 was used a lot more in the scientific world, and 3 was used a lot more in like the programming world. Now 2 is kind of getting like end of life, so it won't really exist anymore. But for you, there's one big key difference that you will absolutely come across in these videos versus what we're going to be doing here. Let me go back to the code real quick. Look at this right here. Take a good look at it, study it, kind of understand it. There might even be something kind of emphasized on the screen. And now I'm going to go back to the other screen where it showed like the thumbnail of the video where it had like the print hello world. Can you kind of see that there? What's missing there? The parentheses, yes. That's because one of the differences, and a lot of people get really angry about this, one of the differences between Python 2 and Python 3 is with prints, in 2 you didn't need the parentheses, in 3 you did. FYI. So in all the code, in those videos, when you see print without the parentheses, know that you should be adding the parentheses. Another one of the issues that might come up, I'm probably going to talk a little bit more about this a little later, but here's another thing that really angered a lot of Python programmers when they made Python 3, And a lot of other programmers too. Because there was this convention in programming that almost all of the popular programming languages were following, even Python 2. And then Python 3 came along and switched it. And that just annoyed everybody, especially those that had code in Python 2 upgraded and tried to run the same code. Okay, so if I ask you, I'm going to give you a quick quiz. You probably won't know the answer, and I'm only doing this for the purpose of explaining what this difference is. I'm going to reemphasize it a little bit later once we get there. But if I ask you, a typical human being, what is 5 divided by 2? Everybody yell it. 2.5, right? 5 divided by 2 is 2.5. Great. Now here's the funny thing with computers. The values that we look at have types. More on this very, very, very soon. But if we are trying to imagine for a second that we're only working with numbers that are integers, like whole numbers. We're not allowed to have decimals. We're not allowed to have fractions. It's just the way it is. If we do 5 divided by 2, and we can only live in the world of integers, who here knows what the answer is? What's 5 divided by 2 when dealing with integers? Yell it. 2. It's 2. It does something called like truncating. It takes the decimal and it just ignores it. You could have done some division that was like 2.9999999, and if you're dealing with integers, the computer goes, that's just 2. It doesn't round, it just chops it off. So, in most of those programming languages, if you wrote 5 divided by 2, the answer is 2. Unless you are dealing with numbers that aren't integers. Values that do have decimal points. But Python 3 kind of switched this convention a little bit, and it annoyed people. And I'll bring it up once we get there. So those are the 2 key main differences you might come across in the videos of Python 2 when thinking in Python 3. There is a third one that might come across when it comes to some fancy data structure called dictionaries, but that's like end of the semester discussion, so let's not worry about that right now. So if you click these, yeah, and I've got the warning there. I did try to go back and add some of the warnings to the video descriptions on YouTube as well to hopefully help. So there you go. So here I say for next week, well that's not true because we're going to carry right on from now. But that's basically it for the intro lecture. If you had your computer with you, you did the Hello World, you're already a programmer. You're experienced, you're an experienced programmer. You can go home and tell your parents I'm a programmer now, I don't know. Are there any questions about the syllabus, how the assignment, any stuff at this stage? Now is a great time to ask before we start really jumping into the stuff. No questions. Come on. This is going to be really boring if I don't get questions. Yes?
Why do you need the bracket and the quotations?
So the quote, okay. We will be talking about this, once I click next. We're going to be talking about it, but I will give you a bit of a description. So the quotations is to tell the computer, this is what we call a string. A string is just a fancy word of saying, here's a collection of letters that I want you to treat as a collection of letters, not as code, let's say. So let me show you a really quick example right here. If I go here and get rid of the quotes, whoop, we need the parentheses. And I hit run, it's going to get really mad. It's going to be like, whoa, what is hello, what's world? It doesn't know any of that. So when we put it in quotes, it says, just treat this as one chunk of words, like a sentence. Maybe a word, a sentence, who cares? You can even have what we call an empty string, which is kind of funny. There, we printed out nothing. So the quotes are to say it's like a string. It's a word. We call sentences or words that we want to be words strings. The parentheses, that's the convention for functions. When we call a function, we'll say name of the function, open bracket, close bracket. Honestly, Who here has ever written this before in your life? And if everyone doesn't put up your hand, if you don't put up your hand, I know you're lying. Oh. F of x equals, I don't know, x squared. I don't know. Raise your hand if you've written something like that before. Of course you have. What do we call f of x? Everybody. I'll give you a pass because it's muffled. But yes, of course, it's a function. And this is like the variable, like the parameter. And if I say, okay, what is f of 5? What's the answer? So this is the definition of this function. And then if over here I say, like, okay, well, what's f of 5? That gives me what? 25. So this is where I defined the function. This is a function saying, okay, I'm a function. What's its name? F. Why? Because that's the typical simple convention. The parentheses is where you put the input to the function. And this is like, well, what is the function doing? This is the definition. This by itself doesn't really do much. But then if I come along and say, okay, what happens if I plug 5 in for x? Well, it gives me 25. This is where I'm calling the function. So the parentheses here, it's like the parentheses for print. Our function was called print. Do we have an eraser? No, we don't. Well, whatever. Print, hi. This is me calling the function. But the definition for this function is somewhere in the code already. Now in Python 2, print, there was a good reason, arguably, for actually changing it to having parentheses in Python 3. It's because in Python 2, it was classified as a statement, not a function. These are details that will not matter at all at any point in 161, but it's just an interesting fact because you asked. So that was probably way more than you're looking for. Any other questions? See, that was fun though, wasn't it? Questions? All right, so I'm going to hit next down here. All right, values, types, variables, prints, and inputs. A bunch of things that I was literally just talking about, we're going to go over more thoroughly. Well, this one's easy. Have you tried anything interesting in Python yet? Yes, you wrote Hello World, you're a programmer. Great. Did anyone since today, in addition to Hello World, but between the beginning of the class, but before you wrote Hello World, did you do anything interesting yet? No? Oh, come on. Well, you will. All right, so just a warning. We're going to be covering the basics. We got to really start at square one because we assume no knowledge. For some people, it's going to feel really slow. For other people, it might feel fast. For some people, you may have done this before already. I know, I'm sorry, but we got to start here because we assume everyone's on the same page, which is they know nothing. So, warning. Now, let's take a second. And so for the first two activities, you can talk to each other about this, or you can just kind of think and ponder yourself. But for the first one here, I want you to think or maybe talk to one another about what exactly is computation. It's a word you've probably all heard before a billion times, but have you ever really thought about what it means? And really, like, what's a computer? And what's a program? These are words you're familiar with, but try to, like, well, what do they mean? Take a moment, think about it. Maybe talk amongst yourselves. See if you disagree. Go, chat. Maybe if you're all thinking in, reflective, fine. Okay, don't just Google it. I'm just teasing you. All right, so I saw a couple of people actually look up the definition, but even if you looked up the definition and you kept up looking at different definitions, you might actually kind of find not necessarily everything aligning great, but there is proper definitions of these things. Now let's take a second and also think, okay, computer. Who here can identify a computer? Okay, everyone point to a computer. There. Can anyone point to a different computer? Yes, you're absolutely right. That's not kind of what I meant. But, okay, you're pointing at like a calculator. Okay, interesting. I'm trying to think of like a different type of computer. What are you pointing at?
Is that a smoke detector up there?
Yeah, sure. Yeah, I'd say that's one. How about a different type of computer? Your phone? Yeah. You know what's interesting is a lot of the computers that you're pointing at are actually kind of like the same type of computer. Can anyone think of a different computer? Your brain? Yeah.
The microphone?
The microphone? I don't know. Maybe. I don't know how complex that one is. I mean, I suppose arguably we could make an argument that it is, even if it is a simple one. Now, the point I'm making here is, so actually, let's take a second and go back to the brain. You may hear like, oh, you know, your brain's it's analogous to a computer. No, it's not analogous to a computer. It is a computational system. There's no ifs, ands, or buts about it. A computer is a thing that does computation. So things like logical operations, mathematical operations, stores information, recalls information, finds correlation in information. Your brain is one heck of an information processing system. It's a computer. There's no ifs, ands, or buts. It doesn't work like those computers do, but it's a computer. The cells in your body are there's a lot of computation going on in there. There's a lot going on. Computers are everywhere. Even something as simple as a key lock is kind of a computer. It gets some sort of information. It stores information in a certain way. It's like a computer. I mean, in fact, we kind of like program that computer by setting the height of the little like pins in the lock, which is interesting. These are all computers. So computer science isn't just about these things. I mean, we created these things because they're easy for us to program and they're pretty general. We can do, whatever we want with them. But computers are much broader than just those boxes you've got, which is pretty cool to think about. Now, what's a program? Well, people are perhaps a little bit more familiar with this. But a program, it's kind of like a set of instructions to do something. It's actually like a recipe. Anyone here bake a cake before? Bake cookies, bake anything? Like that recipe, it's a program, but we call it a recipe. But it's a series of instructions that if you follow, you'll get what you're doing. It's a program. I'm not being funny with my definitions. It is. It's a program. Who here ate breakfast this morning? A number of people. Okay, cool. So here's what I want you to do. If you didn't eat breakfast this morning, pretend you did. And maybe talk to one another and take turns explaining to each other what were the basic steps you had to do, one at a time. Like create a program of what you did or what you would do to make breakfast. Right? Go, try that. See if you can turn that into a set of instructions that someone could reasonably execute. All right, I'd love to keep it going, but for the sake of time, let's just do a quick demonstration. Who here is bold enough to tell me their instructions for making breakfast this morning? I need a volunteer. And I'll just pretend I'm executing it, like I'm a robot. Who? You didn't eat it? I didn't hear you.
You volunteered.
You volunteer? No, you don't volunteer. Well, someone's got to volunteer. Okay, at the back, what did you do?
I woke up in the morning.
Okay, you got up. I'm you. Yeah, I'm up.
I walked over to the Keurig machine
You walk to the Keurig machine. Well, hold on. Where is that?
in my room.
Well, where is it?
It's like on my it's like on this little space I have for like putting stuff on like cabinet.
All right, but okay, if I'm standing here, is it? I get out of bed. Bed's right here. Is it over there? Is it there? Is it there? Where am I going?
I walk down
Like forward?
and then I take a left turn.
Okay.
I walk towards the Keurig machine.
There it is. Yeah.
Then I hit the button.
You hit the button.
I take the pot out.
Well, where's the pot?
Yeah, I take the pot out
From where?
from my cabinet.
From the cabinet. Well, where's the cabinet? Oh, up here. Okay. So, I mean, it's closed. I can't get it.
I open it.
Okay, you open it. All right.
Take the pot out.
Take the pot out. Where are they? Is it just a cabinet full of pots?
Yes.
All right. Good answer. I take the pot out.
I open up I then take it down to the Keurig machine.
Okay.
Pop open the thing, the top, the lid, whatever you want to call it.
Yep.
Put it in.
Which way? Like side? Like just jam it in there, or
Depends on the feeling.
it depends what your day is like. Yeah.
I just put it in.
Okay, you put it in.
Slide the top down.
Bang. Okay.
Then reach up and grab. Then reach up to the other cabinet.
Okay. Is it there? Is it there? Is it over across the room?
Reach up beside the pot.
It's beside the pots. A minute ago, you just said it was a cabinet full of pots. All right, we can stop now. We can stop now. I was actually being kind of nasty because I actually wanted to emphasize something called abstraction. I mean, I could have even gotten more nasty. We were like, okay, go walk to the thing, and I go like, well, how do I walk? Move your leg. How do I do that? You know, we actually live in a world where we do quite a bit of abstraction. Who here can tell me how to make spaghetti? What do? You just boil water, add spaghetti, done. That's it. Wait 10 minutes. Done. That's it. A human could listen to that instruction. But imagine telling a robot, go boil water. The robot's like, what? Like we live in a world with abstraction. We're lucky. We don't have to talk about those nitty-gritty details. But if we wanted to get really crazy, we could go all the way down to like neurons firing in terms of doing stuff. Like there's abstraction all the way down and all the way up. So I was being kind of nasty, getting more and more specific for no reason other than just to be nasty. But you can see how abstraction is kind of important. Anyways, who here has heard the term debugging before? If you haven't, you're going to get very comfortable with, well, I don't know about comfortable. You're going to become very familiar with it at least, because this is going to be most of what you actually do in this course. It sucks, but this is what programming is. Programming really, people have a wrong sense of it. Programming really means debugging 98% of your time. And the other 2% is writing code that's wrong that you need to debug. Get used to it. I'm not saying this to be discouraging. I'm saying this to set your expectations right. A lot of people get really worried. They're like, I tried for 20 minutes and it doesn't work. It's like, well, yeah. Come back in 3 hours and see, work at it. You'll get it. You got to take your time. Consider you're in a class where you're writing an essay. Think how long that might take you. For some reason, people expect, I think it's because in the movies, you see all those hackers going like this, right? And it's just completely unrealistic expectations. And they think they should be able to do that and finish their code in 20 minutes, half an hour. No, it's going to take you hours. It's going to. But it's that exercise of debugging, that's where you learn. That's where you go I found the problem. And honestly, debugging, once you get a feel for it and you learn tips and tricks, it ends up being, I don't want to say fun, but it turns into a little bit of a puzzle. Like you're a detective, where you're like, okay, there's a bug in this code, I gotta find it. And you do a little of this, maybe you change something, you hit run, that doesn't work, but something different happened, and because of something different happening, it tells me that maybe the bug's over there actually, and so on. So it's a bit of a logic puzzle. Anyone here see any errors yet? Well, we saw one on my screen when I tried to do the print without quotes. Well, that's an error. That was a bug. Now that's a certain type of bug. And it kind of gave me a hint of what it was. Those types of bugs are kind of usually the easy ones. Logic bugs, those are the real tricky ones. Those are the ones that when you hit run, everything ran, but it gave you the wrong answer. Those are harder to solve, usually. So, Python is a programming language. English is a natural language. Natural languages have a lot of ambiguity in them. It's just, it evolved over time by millions and millions or billions of people using the language. It's just evolved, it's just, there it is. But in formal languages are very strict. And Python, being a programming language, is an example of a formal language. And in formal languages, there's no room for ambiguity. We run into a heck of an issue with ambiguity. And there are limitations on what we can express in formal languages, which is kind of a weird idea because it says that there is some sort of limitation on what I'm allowed to program in Python. But let me put this, just a quick little example. We're going to end on this. If I say, this statement is false, think about that for a second. This statement is false. Take a second and think about that. In fact, let's just end there. And we'll pick back up here on Friday, I guess. And we'll talk about this question. This statement is false.